Hello and welcome to Spark tutorial at Learning Journal. What is Apache Spark? That's the topic for this video. I will give you a quick introduction of Apache Spark. I will cover its technical stack and primary components. Let's start with some background. We already know that when we have a massive volume of data, let's say hundreds of gigabytes or terabytes, and we want to process it for whatever purpose, it won't be efficient and cost effective to do it on a single computer. No matter how big and powerful is the individual machine, you will surely hit a bottleneck at some point. We also know that Hadoop offered a revolutionary solution for this problem. Hadoop solved this problem in two parts, offering a distributed storage and then offering a distributed computing engine or a framework. At a later version, Hadoop also offered a cluster resource manager. These three things together make a perfect recipe for handling big data problems. However, creating MapReduce program has been a black magic. Most of the developers found it hard to code. Many of them also criticized MapReduce for its poor performance. Later, Apache Spark came out of UC Berkeley. You can think of Spark as a compelling alternative or a replacement of Hadoop's MapReduce. If you came here from Hadoop MapReduce background, Spark is 10 to 100 times faster than Hadoop's MapReduce. If you know nothing about Hadoop, it's okay. Hadoop is not a prerequisite for learning Spark. However, you can think of Spark as a successor of Hadoop. But what is Apache Spark? Let's look at the Spark homepage. Lightning fast cluster computing, a fast and general engine for large-scale data processing. Let's look at the Databricks. They are the primary force behind Apache Spark. Powerful, open source, ease of use, and whatnot. That's correct. Spark is indeed all of this. But all that sounds like a marketing pitch. What exactly is Apache Spark? You can define it like this. Apache Spark is a fast and general purpose engine for large-scale data processing. Under the hood, it works on a cluster of computers. But I am still not sure what exactly is Apache Spark. Let me try again. There are two things, a cluster computing engine and a set of libraries, APIs and DSLs. These two things together make Apache Spark. Now look at this diagram. This diagram represents the Apache Spark ecosystem. At the base, you have Spark Core. The Spark Core itself has two parts, a computing engine and a set of core APIs. Apache Spark is a distributed processing engine, but it doesn't come with the inbuilt cluster resource manager and a distributed storage system. You have to plug in a cluster manager and a storage system of your choice. There are multiple alternatives. You can use Apache Yarn, Mesos, and Kubernetes as a cluster manager for Apache Spark. Similarly, for the storage system, you can use HDFS, Amazon S3, Google Cloud Storage, Cassandra File System, and much more. So, one thing is clear. Apache Spark doesn't offer cluster management and storage management services. However, it has a compute engine as part of the Spark core. The compute engine provides some basic functionalities like memory management, task scheduling, fault recovery, and most importantly, interacting with the cluster manager and storage system. It's the Spark core, or we can say the Spark compute engine, that executes and manages our Spark jobs and provides a seamless experience to the end user. You just submit your jobs to Spark and the Spark core takes care of everything else. Now, coming back to the second part of the Spark core, the core APIs. Spark core consists of two APIs, structured APIs and unstructured APIs. The structured APIs consists of data frames and data sets. They are designed and optimized to work with the structured data. The unstructured APIs are the lower level APIs including RDDs, accumulators and broadcast variables. These core APIs are available in Scala, Python, Java and R. We will learn more about these APIs as we progress with the tutorial. Outside the Spark core, we have 4 different sets of libraries and packages. Spark SQL, that allows you to use SQL queries for structured data processing. Spark Streaming, that helps you to consume and process continuous data streams. MLlib, it is a machine learning library that delivers high quality algorithms. GraphX, that comes with a library of typical graph algorithms. These are nothing but a set of packages and libraries. They offer you APIs, DSLs and algorithms in multiple languages. They directly depend on Spark core APIs to achieve distributed processing. Simple, isn't it? Let me quickly recap. The heart of Spark, the Spark core, right? It's an engine and a set of core APIs. The engine heavily depends upon a third-party cluster resource manager and the storage system. The APIs comes in 2 flavors, structured and unstructured. The structured means data frames and data sets. Unstructured means RDDs. Then we have libraries on top of Spark core. SQL, streaming, machine learning and graph processing. That's it. What makes Spark so great? Why is it so popular? At very high level, there are 3 main reasons for its popularity and rapid adoption. It abstracts away the fact that you are coding to execute on a cluster of computers. In the best case scenario, you will be working with tables and using SQL queries. You will feel like working with a database. In the worst case scenario, you will be working with collections. You will feel like working with a local Scala or a Python collection. That's it. Everything else, all the complexity of distributed storage, computation and parallel programming is abstracted away by the Spark core. Spark is a unified platform that combines the capabilities for batch processing, structured data handling with SQL-like languages, near real-time stream processing, graph processing, and machine learning. All of this into a single framework using your favorite programming language. You can mix and match them to solve many sophisticated requirements. Ease of use. If you compare it with MapReduce code, Spark code is much more short, simple, easy to read and understand. The growing ecosystem and libraries that offer ready-to-use algorithms and tools. The Spark community is continuously working towards making it more straightforward with every new release. Great! I guess the session was able to give you a high-level picture of Apache Spark. In the next video, we will deep dive further and try to understand the overall architecture. Thank you for watching Learning Journal. See you in the next session. Keep learning and keep growing.